Alright, so in this video we're going to go over section 6.1, the indefinite integral. So the integration formulas that we are going to be using are going to be these four basic formulas. The first one is the integral of a constant, which is going to be the constant times x plus the constant of integration, and then the usual general power rule, add 1 to the exponent and then divide by that new exponent. Then we have what we typically call the ln rule, and that's because we obtain a natural log function when we integrate, and this works only when the exponent is basically -1. In this guys, this is the same as saying the integral of x to the -1. And finally, we have the integral of the exponential function. So in this case we get itself the exponential function, but we multiply by 1 over a, which is the number that multiplies the x. Where is this 1 over a coming from? Again, keep in mind that when you take the derivative of the function e to the ax, we get a e to the ax. Alright, so what do we do? So to take the derivative of e to the ax, we keep it itself, but we multiply. Now in this case, since the integral is the inverse operation to the derivative, well, so instead of multiplying, that's why we are dividing. So let's go ahead and do a couple of examples in which we can illustrate these formulas. Okay, so let's do the first example. So 6x squared minus the integral of 6x squared minus 3x to the -2 plus 5 plus 12 e to the 3x. Okay, so it would be a good idea to split this into 1, 2, 3, 4 integrals. I'm going to pull the constants outside of the integral, and all the x's I'm going to keep them inside of the integral. So I'm going to have 6 times the integral of x squared dx minus 3 times the integral of x to the -2 dx plus 5 times the integral of dx plus 12 times the integral of e to the 3x rather dx. So we are going to evaluate for individual integrals here. Well, for the first one we are going to use the general power rule, so we're going to get 6, add 1 to the exponent, x to the 2 plus 1 equals 3, divide by that number 3, minus 3 times x to the -2, add 1, we get -1, divide by -1, careful with the signs here, you will see what's going to happen there, and plus 5 times the integral of dx, which is just x, and plus 12 itself, e to the 3x, but again keep in mind that we divide by the number that multiplies the x, in this case 3, and don't forget the plus c. So we are essentially done with the calculus here. Now we need to simplify these numbers and clean up negative exponents. So 6 divided by 3, what are we going to get? We get 2x cubed. Negative times negative, you might want to use the smile rule. See the smile? You can see some smile means smile be positive, x to then actually 1 over x, and then plus 5x, and 12 divided by 3, that's going to give us a 4, e to the 3x plus c, which give us final answer. Okay, let's do another example in which we are going to have radicals, exponentials with negative exponents, and division. So this one is going to have a little bit of everything. Alright, so I'm going to change all this radical into rational exponents. Keep in mind that square root of x is the same as saying x to the 1/2. Divide by 2 minus 2 times x to the 1/2. Okay, and I'm going to rewrite this exponential instead of saying negative x to negative x over 6, I'm going to rewrite it as negative 1/6 of x, right? That is, multiplying by negative 1/6 is the same as dividing by negative 6. It is the same. And the thing is, it's going to be better for us to see it this way when it comes to integrating the function. So that times the x. Alright, I'm going to move this this x to the 1/2. I'm going to move it to the numerator with negative exponent, because we cannot just integrate this when this is in the denominator. So I'm going to go ahead and write I'm going to write 3 integrals, in fact, at the same time. So I'm going to have 3/2 times the integral of x to the 1/2 dx minus 2 times the integral of x to the negative 1/2 minus the integral dx minus e to the negative 1/6 of x dx. Now we are ready to integrate this. So we're going to get the following: 3/2. Well, in this case, I'm going to leave the addition indicated. So x to the 1/2 plus 1 divided by 1/2 plus 1 minus 2 times x to the negative 1/2 plus 1 divided by negative 1/2 plus 1, and minus, okay, I'm going to leave some space here, we get itself the exponential, but we divide by negative 1/6. And be careful here, I'm going to put parentheses here. This might be kind of tricky to read. So okay, let's clean this up. So 1/2 plus 1 is going to give us 3/2. Negative 1/2 plus 1 is going to give us 1/2. Okay, so that will be 3/2 times x to the 3/2 divided by 3/2 minus 1 minus 1/2, again is it's 1/2, to x to the 1/2 divided by 1/2. Okay, and in this case, number 1, a negative times a negative will give us a positive. Alright, it's going to give us a positive. And dividing by 1/6 is the same as multiplying by its reciprocal, which is 6 e to the negative x divided by 6. At this point, we can go back to this notation. Either way, again, they represent the same. Multiplying by a 6 is the same as dividing by 6. Alright, so it would be a good idea to keep cleaning this up. Okay, so notice something interesting here. Notice how this 3/2 cancels these 3/2. And in this case, dividing by a half is the same as multiplying by 2. So this 2 times 2 is going to give us a 4. So what do we get at the end? We're going to get x to the 3/2 minus 4 x to the 1/2 plus 6 e to the negative x over 6. The whole thing, oh, plus c. Be sure to put the plus c here as well, plus c. Every time you stop using the integral sign, we are supposed to write that plus c, and that's final answer. Alright, let's go ahead and do a few more examples. In some cases, we won't be able to just directly integrate this. Look at letter C. So in this case, I cannot integrate this as a product. And again, keep in mind, we cannot just distribute the exponent along sums or differences of terms. So what are we going to do here? So first we're going to do some algebra. That is, I'm going to expand the binomial. Integral of x squared times x squared plus 2 times 6, which is 12, x plus 36 dx. And then what do we do next? Well, I'm going to distribute the x squared over each term and multiply to get 3 simpler terms to integrate. So I'm going to get the integral of x to the 4th plus 12 times x cubed plus 36 x squared dx. Okay. Now I'm going to write this as three separate integrals again. So that's the integral of x to the 4th dx plus 12 times the integral of x cubed dx plus 36 times the integral of x squared dx. And in this case we are ready to just integrate these three guys. So this is going to be x to the 5th over 5 plus 12x squared x to the 4th over 4 plus 36 x cubed over 3 plus c. And we are essentially done with the calculus. However, notice we can simplify this 12 over 4 and this 36 over 3, which is going to be in each case, well, this one stays the same. 3x to the 4th and 36 over 3, that's going to give us a 12 x cubed plus c. And this is final answer for this one. Alright, what about letter D? So for letter D, okay, just like the previous example, letter C, there is no such thing as a product rule or integration of a product. Likewise, there is no quotient rule for the integrals, right? So the trick here is we are going to split into 3 fractions together. Okay, so this will be the integral of 4x to the 4th over x plus 6x over x minus 7 over x dx. I'm going to simplify in each case. For example, here we can use loss of exponents, x to the 4 divided by x. That's going to give us 4 times the integral of x cubed plus, in this case, the x's cancel. Notice how these cancel. Simply 6 times the integral of dx minus 7 times the integral of 1 over x dx. Alright, so we are ready to integrate this individually. So in this case, we're going to have 4x to the 4th divided by 4 plus 6 times x, 6x, and minus 7 times ln. This is one in which we have the ln rule, ln of absolute value of x, and then plus c. Can we simplify anything a bit further? Yes. Notice how these 4's can go away, leaving us with x to the 4th plus 6x minus 7 ln of absolute value of x plus c. And final answer. Alright, another one like this. Letter E. Letter E looks very interesting in terms of the algebraic technique that we are going to be using before we can even do any kind of integration. Again, as we mentioned on the previous examples, there is no such thing as quotient rule, and then so we need to simplify this rational expression. Again, keep in mind that we cannot just cancel x's with numbers. We need to do some factoring in the numerator. Maybe you see the form right here, a squared minus b squared, which is the difference of squares. So that's what I'm going to do, factor the difference of squares. Alright, so I'm going to have the integral of x plus 5 times x minus 5, and just bring the x minus 5 that we had from before. Alright, notice how we are using the form a plus b times a minus b. Okay, and notice something interesting as well. Notice how we can cancel x minus 5 with x minus 5. Those simply go away. and we get the integral of x plus 5 dx, which we can split into separate integrals. The integral of x plus 5 times the integral of dx. This one is just going to be x squared divided by 2 plus 5x. Don't forget the plus c. Alright. Let's do one more. Let's do the last example right here. So in this case we have the product of some kind of linear polynomial and a cube root. Alright, again as usual, first of all we need to take care of this radical factor. We need to represent it in a different way by writing it as rational exponent, that is 1/3. And then distribute for every single term inside of the parentheses. So we are going to have the integral of 4w to the 1/3 minus 7 times w. Okay, keep in mind over here that there is an invisible 1, and then when we multiply the same variable, what do we do with the exponents? We add the exponent, that is 1 plus 1/3. That is going to be 1 times 3, which is 4. 1 times 3, which is 3, plus 1 equals 4/3. Alright. So we're going to get 7w to the 4/3 dw for the whole thing. Alright. So let's write this into separate integrals. That is 4 times the integral of w to the 1/3 dw minus 7 times the integral of w to the 4/3 dw. Alright. So we can now integrate. So again, in this case we are just going to use the general power rule. Add 1 to the 1/3, we get 4 times w to the 1/3 plus 1 divided by 1/3 plus 1 minus 7 times w to the 4/3 plus 1 divided by 4/3 plus 1. Again, if you want to express that one in terms of thirds, this is the same as saying 3/3. 3/3. 1 is the same as 3/3. So that way you can add fractions within the same denominator, which will make it easier. So 1/3 plus 3/3, that's going to give us 4/3, or I'm going to have 4w to the 4/3 divided by 4/3 minus 4 plus 3, that's going to be 7/3. So 7w to the 7/3 over 7/3 as well. Yes, as you might be thinking, can we do this 3/3 here as well? Of course, you can do it here, right? Not just in the denominator. Ultimately, it's the same operation, right? So the tricky part here will be dividing by a fraction. It's the same as multiplying by the reciprocal. So in this case, I'm going to have, and I'm going to write these reciprocals in a different color just so you can see how am I going to cancel. So 4w to the 4/3 minus, I'm going to leave some space. I'm leaving some space, on purpose so you can see what I'm doing. Oh, by the way, plus c plus c plus c. And we're almost there. So this 4/3 becomes 3/4. This 7/3 becomes 3/7 when we multiply these quantities together. And notice how these 4's go away, these 7's go away, and we are finally left with the following: 3 w to the 4/3 minus 3w to the 7/3. Alright? Plus c. Final answer. And this is the end of this section.